Hello, welcome to the sixth session. In this session, we'll be discussing verifiable presentation submission. This lecture is part of the foundational series designed to help you understand the basics of the OmniOne OpenDID platform. If you follow along step by step, you'll be able to grasp the essential processes with ease. Let's get started. First, let's go over the basics of VP submission. VP submission is the process where a user selectively proves their credentials in response to a verification request. For example, it's like submitting my digital diploma from Korea University to a company that acts as a verifier. The process involves the user creating a VP, which the verifier then checks for authenticity and validity. This lecture will focus on the core aspects of VP submission. For more detailed information, please refer to our GitHub pages. You can scan the QR code to access the link. Before we begin, let's quickly review the most basic concepts related to VP submission. First, a VP, which stands for Verifiable Presentation, is a format for submitting only the necessary information for verification, based on VCs. Next, a verifier is an entity, such as an institution or organization, that verifies the authenticity of a VC or VP. A verifier can check VCs issued by entities like governments, schools, or companies. With these fundamental concepts in mind, let's now explore VP submission step by step. On the OpenDID platform, VP submission consists of two main phases: a preparation procedures and a submission procedures. The preparation procedures, as the name suggests, involves planning for the VP submission in advance. The submission procedures is where the actual VP submission occurs, involving an offer and the submission itself. We will now explain each of these stages in more detail. First up is the preparation procedures. This is where the necessary planning for VP submission is done beforehand. These are tasks performed in advance by the verifier, or the verifying entity. This can be broken down into four main parts: service definition, service device definition, transmission media definition, and message format definition. These terms might seem a bit difficult at first, but as we go through them one by one, you'll find them easy to understand. First is the service definition stage. This is where the verifier defines the service in advance. The service here refers to the function or service the user will ultimately access after their VP is successfully verified. For example, after I submit my Korea University student ID to the library and it's verified, I can use the library's book borrowing service. This book borrowing service is exactly what we mean by service here. This service definition includes both basic information about the target service and the policy for VP submission. In other words, it's a concept that includes not just the service itself, but also what kind of VP needs to be submitted to use it. Examples of services include login, sign up, age verification, and identity verification. The VP policy can include various rules, such as the type of VC, allowed issuers, required and optional claims, and authentication methods. Next is the service device definition stage. This is where the verifier defines the response mechanism in advance. In some cases, a response mechanism is needed between the authorized app and the verifier to assist or relay the VP submission. For example, to submit my Korea University student ID to the library, there needs to be a response mechanism that transmits the action, like tapping an NFC tag or scanning a QR code. This response mechanism could be a simple hardware device, a software application, or it could exist in various other forms. Next is the transmission media definition stage. This is where the verifier defines the delivery method for the submission offer in advance. As I'll explain in more detail later, for a user to submit a VP, an offer must first be sent from the server. The user then submits the VP based on this server-sent offer. So, what's important here is defining the method through which the offer will be delivered to the user. This delivery method could be, for example, a QR code or a push notification, among other options. Ultimately, the offer is delivered to the user's authorized app through this defined delivery method. Next is the message format definition stage. The elements we've discussed, like the response mechanism and the offer, can come in various types. To ensure these different types are interpreted consistently between the sender and receiver, the message format must be clearly defined. In other words, this is the stage where the structure of the data to be transmitted, the field names, and the meaning of each field are mutually agreed upon, so they can be understood correctly. The verify offer payload you see on the screen is a specification used in OpenDID, which you can refer to. As you can see, there are fields like offer ID, offer type, mode, and device. This process involves predefining what each of these fields means and how they are structured. Next are the submission procedures. After the preparation procedures is complete, this is the stage where the actual VP submission takes place. First, let's talk about the offering phase. To reiterate, for a user to submit a VP, an offer must first be sent from the server. The user then submits the VP based on this server-sent offer. The process for this is the offering phase. The first step is creating the submission offer payload. In this step, the payload is generated based on the rules defined in the message format definition stage we discussed earlier. The payload is created according to a predefined structure, such as generating a unique identifier for each transaction. The next step is to send this created offer payload to the user. Here, using the delivery methods we discussed earlier, the offer is sent to the user via methods like a QR code or a push notification. The next step is the user receiving the offer. The user's authorized app analyzes the received offer and extracts the necessary basic information for the next step, which is the submission. After going through the offering phase, we move on to the submission phase. Next is the submission phase. The offer has reached the user through the previous offering phase. Now, based on this, the submission phase between the user and the verifier proceeds. The submission phase begins with the user's request for a verify profile. Simply put, the verify profile is metadata containing the verifier's information, filter conditions for the submittable VCs, and the VP submission method. Through this verify profile, both the user and the verifier can clearly confirm in advance the algorithm used to securely encrypt and transmit the VP, and what attribute information is required for the submittable VCs. The user then, based on this profile information, selects a suitable VC for submission, creates a VP, and securely submits the VC information to the verifier through the VP submission process. There are three main modes for VP submission. First, there's the direct mode. As the name suggests, this is the simplest method where the user's authorized app sends the VP directly to the verifier. Next is the indirect mode. In this method, the VP is not sent directly but is submitted indirectly through an intermediary such as a service app, NFC, or Bluetooth. Finally, there's the proxy mode. Here, a proxy server exists between the authorized app and the verifier, and the VP is delivered through this proxy server. So, what are the components of a VP? A VP is composed of a combination of the VCs we've discussed. Therefore, a VP fundamentally includes these VCs, which constitute the verifiable credentials. As in the example explained earlier, to use the Korea University Library Service, I can extract only the student ID number claim from the various claims in my Korea University student ID. And this becomes one of the components of the VP. These verifiable credentials form the basis of the VP. And it also includes presentation metadata and a proof. First, the presentation metadata is, literally, the area where meta information about the VP is stored. For example, the VP's submission time, expiration date, and schema information are all part of the metadata. Next, the proof is, as the name implies, proof information. It's information that guarantees that the submitted VP was indeed submitted by a trusted user. This includes the wallet's digital signature information. And if the signature is verified using this proof, it confirms that the VP was submitted by the correct sender. Next, let's look at some real-life use cases for VPs. First, in the case of a standard VP submission. For example, when logging into Government24, I can submit my ID card VC as a VP to log into the service. The verifier checks the necessary attributes, and if the verification is successful, allows the login. This is the most common form of VP submission. Next is the case of ZKP, or Zero Knowledge Proof, submission. For example, when buying alcohol at a convenience store, I can use the convenience store app to prove only that I am over 19 years old. This is possible through Zero Knowledge Proof, a method where I prove I am over 19 without disclosing my actual age. This goes a step beyond selectively submitting only the necessary information from a VC, and is a VP submission method with enhanced privacy. And that concludes our 6th lecture. I hope this session has helped you understand the OpenDID VP submission process. Thank you for your time.